Welcome to video 4.7, Computing Slope from Coordinates. So far you've learned how to look at the graph of a straight line and measure its slope. Here we're going to move beyond that and use coordinate points to compute slope. So let's start with a bit of review. Two things that you need to remember about slope to frame our lesson. Slope is a measure of how steep a line is on a graph, and we calculate slope by taking rise divided by run. So I'm going to start this lesson by going through an example together. So look at example number 1. So here we have a straight line passing through a number of different points. First, we're going to solve for slope here, learning the way you've already taught you, and then I'm going to show you the new way. So we know that the formula for slope, and m means slope, is rise over run. So the rise here is 1, 2, 3, 4. And the run is 1, 2. So my slope is 4 over 2, which can simplify to just positive 2 because 4 divided by 2 is 2. So I did that by counting boxes on the graph. But now I want to show you a different way that will get us the same answer, which is what if I only had the coordinates and not the actual picture of the graph? Let's look at rise. Rise is how high the graph goes. So right now, I just want you to look at the y coordinates for these 2 points. Remember, y coordinates are the second coordinates. So we have 5 and we have 1. If I want to know how much this graph goes up, I can take the second coordinate, 5, subtract 1, because that's where I started with. So I started at y equals 1, and I went up to y equals 5. So I can figure out the rise by going 5 minus 1. In terms of the run, I started at a horizontal x equals 1, and I went over to x equals 3. So I can figure out the run by taking the second x coordinate, 3, and subtracting 1. So here, the slope is 5 minus 1 over 3 minus 1. 5 minus 1 is 4. So that simplifies to 4. And 3 minus 1 is 2. You'll see we got the same answer. So you can count boxes or you can use coordinates. So I did this with a very specific example. Now if you turn the page, I'm actually going to give you a formula, and then we're going to practice using the formula. So here's the formula. Start by copying it down. We previously learned that slope is rise over run. Rise just means how much does the y value change? How much is my line going up or down vertically? So I can do that by taking the difference, that means subtraction, between my two y coordinates. That would be my rise. My run is how far does the graph move horizontally? So I can find the run by taking the difference between my two x coordinates. Now let's look at an example. So here I have a graph. I've got 2 points on that graph. It doesn't, and this is really important, it doesn't matter which point you call point number 1 and which point you call point number 2. It'll work no matter what. So I'm just going to go over here. I'm going to say that point number 1 on this graph has the coordinates -1 and -2. So remember, we always do x first and then y. Point 2 has the coordinates +2, +2. So if this is point 1, then -1 is my x value for point 1, and -2 is my y value for point 1. Point 2 is 2, 2. This is x number 2 and y number 2. So the first thing is just to get your 2 points that you're using, identify the x coordinates in each, and call one of the points number 1 and one of the points number 2. So here's my slope formula that you just learned and that you're going to need to memorize. y2 minus y1 over x2 minus x1. So now we're just going to substitute in numbers. y2, I go to point 2 and I go to the y coordinate. So that's a 2. Minus y1. I go to point number 1 and I look at the y coordinate. It's -2. All right, let's go to x. I go to point 2. I look at x, and it's 2. I go to point number minus x1. I go to point number 1. I look at my x-coordinate, and it's negative 1. So you got to be good here at adding and subtracting positive and negative numbers. When you subtract a negative, it turns into a positive. So 2 minus negative 2 is the same thing as 2 plus 2, so it's 4. 2 minus negative 1 is the same thing as 2 plus 1. When you subtract a negative, it turns into an addition. So that would be 3. And so according to the formula, my slope is 4 over 3. And here you have a graph, so you can double check it. 1, 2, 3, 4. 1, 2, 3. That makes perfect sense. So here, before I do this example, I'm going to encourage you to pause the video and see if you can do this one on your own, and then see if you get it right based on my example. Remember, the first thing you need to do is get the coordinates of the points. One of them you're going to call point 1, one of them you're going to call point 2. It doesn't matter which is which. Then, once you've identified which coordinate is which, you're going to plug it into the formula. So I'm going to call this point 1. So it has the coordinates x equals 0 and y equals 4. And I'm going to call this point 2, which has the coordinates x equals positive 3 and y equals negative 3. So now I need to substitute into the formula. y2, I go to point 2, and I choose the y value, which is negative 3, minus y1. So now I have to go to point number 1, go to the y value, and that's a 4. So negative 3 minus 4. Now I need my x. I go to point number 2. It's the x value for point 2 is 3. Now I go to point number 1. My x value is 0. So negative 3 subtract 4. You might need to use a number line for this. Negative 3 subtract 4 is negative 7. 3 minus 0 is 3. So I end up with a slope of negative 7 over 3. Let's check that against our graph. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. It worked. So you might be wondering, why bother doing all this formula work if I can just count boxes on the graph? And the answer is that sometimes you won't have a graph. So if you look at this last example, example 4, you're asked to compute the slope of a line that passes through 5, 9, and 2, 15. I can't count boxes because I don't have a picture of that graph. But if I have two sets of coordinates, I can get the slope of what that line would be. So let's call this, what I'm highlighting here, point 1. And let's call what I'm highlighting in blue point 2. So that means that y1 and x1 need to come from the point highlighted in yellow, and y2 and x2 need to come from the point highlighted in turquoise. Now again, I've said this, but I'm going to say it again. It doesn't matter which is point 1 and which is point 2. You can do it either way, so long as you're consistent. So if you choose that 5 and 9 is point 1 or point 2, it doesn't matter. You just can't make one of the coordinates point 1 and one point 2. So let's start substituting in. y2, I go to point 2 and I look at the y value. Remember, the y value is always the second one. So it would be 15 minus y1. So I go to point 1, the y value is 9. X, so I start with x2, I go back to my turquoise point, point 2. The x coordinate is always the first coordinate, so that would be a 2. Subtract x1, I go to point 1, which is highlighted in yellow, and I subtract the x value, the x coordinate, which is the first one, which is 5. So let's simplify. 15 minus 9 is 6. 2 minus 5 is negative 3. 6 divided by negative 3 is simply negative 2. And so my slope is equal to negative 2. And that's the value of using the formula, is it allows you to calculate slope even when you don't have a picture for counting boxes.